Hello everybody, today we're going to look at solving quadratics by factoring. In my last video we talked about solving quadratics, so if you need some assistance with that, make sure you refer back to that. So today we're going to start with the zero product property. And it states that if A times B equals 0, then A, B, or both are equal to 0. Let me give you some examples. If I have 3 times 0, of course the result for that is going to be 0. If I have 8 times 0, of course the result there will be 0. Again, if I have x times 0, whatever x is, doesn't matter, my result will be 0. Now we'll use the zero product property here in just a minute with some binomials when we solve quadratics. But I wanted to define what does it mean to solve a quadratic. So let's look at an example here. We'll look at this graph here. Notice we have two x-intercepts for this graph. These become our solutions. So where the graph crosses the x-axis is how we define a solution. In this case, it would be -2, 0, and this one over here is 4, 0. So our solutions for this quadratic would be -2 and 4. So we would say x equals -2 and x equals 4 are solutions for the quadratic. Another example that we can look at, another representation we can use, is a table. If we look at a table, we can also see the solutions show up. Now, they don't always show up in a table because they may be not integers, such as x equals 1.4 and so forth. Okay, let's return to the zero product property for a second. When we go to solve quadratics, what we'll end up with, for the most part, when we're factoring at least, we'll end up with something that looks like this. Two binomials equal to 0. Now remember, this is a product. That's why we call it the zero product property. Product. So what's happening here is this is our A and this is our B, and the parentheses mean times. So we're going to use that fact when we go to solve quadratics. Again, zero product property. Let's look at an example of a quadratic that we can solve pretty easily. When we have x squared in the beginning term, it factors very easily. So let's take a look at that for a second. So when we see this x squared, and we remember that's 1x squared, it's easy to split up. So what does that look like? Well, the first thing we're going to do when we solve a quadratic by factoring is we're going to replace the y with 0. Because remember the examples we looked at. We had -2, 0 was one solution, and 4, 0 was one solution. And for both of those examples, and true for all cases when we solve quadratics, is that the y equals 0. So that's your first step, is to set y equal to 0 in the equation, and make sure that you get all the terms on one side. Okay, in this case they're all on one side, but I could rearrange that equation. Let me show you what that'll look like. So for example, if you were given to start with x squared minus 2x equals 8, again, we would want to get it to equal to 0 first. So make sure, in case you ever run into that case, the first thing you're going to do is collect all of your terms on one side and set it equal to 0. So how does this factor? Well, remember, when we have x squared, we don't need a diamond and a rectangle, although we will look at an example today where we do need them. We don't need them in this case because we have x squared. And remember, it splits up x and x because x squared is x times x. So you only need to ask yourself two things that multiply to this number but add to this number. So two numbers that multiply to -8 but add to -2. In this case, it's going to be +2 and -4. So our solutions are forthcoming. We're not quite done with the solutions yet. So at this stage, once we have it factored, our last step is to take each factor and set it equal to 0. For example, x plus 2 equals 0. And then we solve for x. We're going to subtract 2 from both sides. And we get x equals -2, which is the solution I used in the first example. And again, we take our factor, set it equal to 0. In this case, we're going to add 4. And so we get x equals 4. And there are our two solutions. And remember, those are ordered pairs. -2, 0 and 4, 0. Okay, before we get into a little more complicated example, I just want to remind you how factoring trinomials works with the graphic organizer. So remember, we have ax squared plus bx plus c. It's the general form for a quadratic. And we're going to use what I call the diamond. We're going to put ax squared times c up top. We're going to put our bx term in the bottom. Then we're going to create a rectangle, and we're going to fill in ax squared and c on a diagonal. Then we're going to figure out the sides of the diamond that make up the factors of ax squared minus c that sum to bx, and then we're going to put those on the side. So let's take a look at an actual example here. Okay, so we have 4x squared plus 12x plus 9, and remember, we're going to set that equation. Sorry about that, I had a little technical difficulty. So we're going to set our equation equal to 0 before we get started. And what we're going to do is we're going to do ax squared times c. So it's the first term times the last term. We're going to put that up top, 36x squared. We're going to put our bx term down below. Bx term goes below. And then we're going to figure out factor pairs of 36. So two things that multiply to 36 but add to 12. Now, if you can do this mentally, that's great. But if you have a complicated example, this one's not too bad. You could just list out your factors of 36. So 1 times 36, 2 times 18. We have 3 times 12. And we have 4 times 9. And finally, we have 6. Oops. And finally, we have 6 times 6. So as we look at that. So we're looking for the pair that adds to 12. And in this case, obviously, it's going to be 6 times 6. So we're going to put a 6x and a 6x. Now remember where those pieces go. These two sides of the diamond go on a diagonal. So they need to go on a diagonal here. And then we're going to bring over our other pieces from the original equation. So in this case, I have 4x squared, which is our ax squared term, and our 9, which is our c. At this point, we need to factor out the sides. So we're going to talk about rows and columns. So the 6 and the 9, the biggest number that divides both of those is 3. The biggest number that divides 4 and 6 would be 2. And don't forget there's also an x in common there. And then our first column here, 4 and 6, 2 divides both of those evenly. And there's an x. And then 6 and 9 is a 3. So our final factors here are 2x plus 3 and 2x plus 3. So notice we have a repeated factor here. And remember that equation is equal to 0. So at this stage, to finish the problem, we need to take our factors and set them equal to 0. So I'm going to give us some room here that we can do that with. Okay, so what we want to do is, first of all, before we go any further, I just want to point out that we have two different versions of the same equation. So I want to call this the addition version. We're adding terms together. And this one is the multiplication version. So we turn an addition problem into a multiplication problem. Okay, make sure I'm spelling that right there. Addition problem into a multiplication problem. So we have two versions of the same equation. So remember, our last step here is to take our factors and set them equal to 0. So in this case, I have a repeated factor. So I only need to do this one time. If they were unique and different from one another, then we would have to do this twice. But in this case, we just do this process once. So we take our factor, set it equal to 0, because remember, it's a zero product property. A times B equals 0. Therefore, either A, B, or both of them are equal to 0. So we're going to use that fact. So here I'm going to subtract 3, and then I'm going to divide by 2. So I get x equals negative 3/2. And that's my solution. Now the question I have here is, how do we check our solution using a graphing calculator? So we're going to look at that on the graphing calculator here. Okay, so on the graphing calculator here, notice in my y equals, I put in my original equation we were given, 4x squared plus 12x plus 9 equals y. And then when I go to graph that, notice what happens. I have a solution showing up here at negative 1.5. We can see that right here. This is negative 1.5 or negative 3/2. When we go to look at the table, take a look at the table for a second. And what we're looking for, notice, in this case, it doesn't show up because we have negative 1.5. Now, if you wanted to check, you could change your table settings, just as a side note here. So if you go to second window, you get table setup. And I can tell it to start wherever I like. I'll tell it to start at 0. And now I'm going to tell it, instead of going in 1s, I want to go in 0.5s. Now, this is somewhat of a tedious process if you're trying to find something that's like 1.37, but if it's in half, it's not too bad. So now let's return to our table, And we should be able to see our solution now. Remember what I'm looking for. I'm looking for when y equals 0. So as I scroll up here, there it is, negative 1.5, comma 0. Now, the reason I brought up the graphing calculator is I wanted to show you how you could take your original equation and check the graph to the new equation that we came up with, the multiplication version. So remember what we had 3x plus 2 was our factors, and they were repeated factors. So I could type in 3x plus 2's, or I could use a squared here, because that's what that means. So now let's go back, and this color is going to be red. So what we're looking for is that the blue graph gets covered up with the red to make sure that it's the exact same equation. So let's go take a look here as it graphs. So we got the blue one showing up, and over the top of that should be the red one. Okay, so I caught my mistake there. That's a good example. So notice I put the wrong numbers in, and this is what we got. So that tells me the factors I put in were not correct. So I apologize for that. Instead of starting the video all over again, I'm going to fix my mistake and use that as a learning tool to show you that if you didn't get the right answer, you'll get two different graphs. I switched up my 3 and my 2 as I was going through there. So I'm going to now switch it back to the ones that we started with. So our original factors that we found were 2x plus 3 squared. Now let's test it. So let's take a look at what happens there. So here's the blue equation. And right over the top is the red one. So that confirms that we have the right factors, and we can also find our solution right there. Real quick, how do we find that solution using a graphing calculator if we weren't trying to factor maybe some other way? We'll go over that real quick. So we have a second trace button. Trace button's right there. And we talked about maximum and minimums the other day. We can also find our solutions by using the 0 function. Because remember, y equals 0, so we're going to use 0. So I'm going to hit enter there. And it's going to ask me similar questions to the max problem we did the other day. It's going to say left bound at the bottom down here. See that? And I need to be left to where it crosses the x or touches the x-axis. So we're going to hit enter, and it's going to ask me right bound. So I need to be to the right of that. And I'm going to hit enter. And then I want to go right over the top of that solution there and confirm that we get the right answer there. And notice it does confirm it for us. Okay, great. So that's a very handy tool, the graphing calculator, checking your solution or even finding the solution without factoring. Good handy tools there. And we've also talked about table setup and how you can change your table settings. We're going to look at one more example of factoring. It's a little bit different form here. Okay, in this example here, I've got 8x cubed plus 2x. Notice this does not have ax squared plus bx plus c form. This is just the ax squared plus a bx. And whenever we have this, we're going to have an x in common between both of these here. So what we want to look at is the numbers first. Is there a common factor that we can factor out of this and then look at it and see what happens? And it looks like the 8 and the 2, we can factor out a 2 out of that and also an x. So this is kind of that example where I was thinking backwards distributive property with you guys. And so we're kind of thinking instead of doing the distributive property, we're actually doing it backwards and we're factoring out. So we asked ourselves the question, if I were to multiply 2x by something to get back to 8x to the third, what would that be? In this case, it would be 2 times 4 would give me 8, and then x squared would give me 4x squared, and then 2x times 1 would give me that. Okay, I'm going to have to reset one more time. I went to the wrong PowerPoint. And again, I know you guys need this video out so you can get your video notes and get through the section. So I'm going to push on through and show you that this is the example I actually wanted to look at. So we wanted, again, the same process I was just talking about, but just a different equation that's going to set up better for us here. So what I want to do here is look for a common factor. In this case, I have a 12 and a 48. So if I factor out a 12 here first, let's see what we end up with here. So again, same idea, backwards distributive property. We're going to factor out a 12, and then ask yourself, what do I have to multiply that by to get back to 12x squared? Well, that would be x squared. And then what do I have to multiply 12 by to get back to 48? Well, that would be a 4. So now I have 12 times x squared minus 4. We have factored that thing. But remember, we want to solve. So we set the original equation equal to 0. And this equation is also equal to 0. Okay. And then we take our factors and set them equal to 0. Notice when we do this, 12 equal to 0 doesn't make sense. It does not equal 0. So while it is a part of the factors, it's not part of the solution. And we look at this factor here. Now this one we can't quite set equal to 0 because it's not all the way factored. If you remember from Algebra 1, this is a difference of perfect squares. So we have x plus 2 and x minus 2. So I'm introducing difference of perfect squares for you guys, as we'll be using that going forward. Now it's factored. So now we can set our factors equal to 0. We have x plus 2 equals 0. And we have x minus 2 equals 0. Again, here I'm going to subtract 2 from both sides to get x equals negative 2. And here I'm going to add 2 to both sides to get x equals 2. These are our solutions. And remember what these represent. These represent order pairs. So this is negative 2, 0. And this is 2, 0. So if you were to look at a graph, and you could use your graphing calculator to check that, what you're going to see is this thing is going to cross at 2 points. It's going to cross at negative 2, 0. And a 2, 0. And since we have a positive term up front, it's going to open somewhat like this. So you're going to see a graph similar to this if you would graph it. Graph the original one or the factored version, this is what you'll see. So that concludes our work on solving quadratics by factoring. Thank you.